In this lesson, we're going to look at how to calculate the volume of a compound shape. That's a shape that's made up of two separate 3D shapes. In this case, we have a cylinder in the bottom and a cone in the top. So we're going to do two separate calculations here, one for the cylinder and one for the cone. So we would look at our formula sheet, get the formula for the volume of a cylinder, which is V equals pi r squared h. We would use pi r 3.14. In this case, the radius is not 6, that's the diameter all the way across. The radius is 3. So times 3 squared, and the height of the cylinder is 13. So times 13. Type all that into a calculator, and we come out with the volume of the cylinder, 367.38 centimetres cubed. Let's work out the volume of the cone now. So we'd go to the formula sheet in the cone, and we'd see that it's a 1/3 pi r squared h. We'd start typing that in, 1 divided by 3 times by pi r 3.14. The radius of the cone is the same as the cylinder, it's 3. So times 3 squared, and the height of the cone is 8, so times by 8. And if you type all that in correctly, you get 75.36 centimetres cubed. Now, the overall volume is the volume of the cylinder plus the volume of the cone. There's two different volumes here, we have to add them together. So you take your two values, add them correctly in your calculator, and you get your answer of 442.74 centimetres cubed. And that's it. With this next example, we have cylinders inside a cuboid. So let's read the question. Calculate the volume of the metal blocks remaining after the holes have been drilled. So these cylinders are missing from the cuboid. So let's do two calculations again, because we can see there's cylinders and there's a cuboid. So cuboid and cylinder. Now, to get the volume of a cuboid, that's not in your formula sheet. You should know that from your earlier maths, and it's V equals length times breadth times height. That would be 40 times 20 times 10. And that comes out to 8,000 centimetres cubed. For the cylinder, we go to our formula sheet, and you would see it's pi r squared h, which is 3.14 times the radius. The radius is not 8 here. The radius is half of that, which is 4. So 4 squared times the height, which is 10. The height is the same as the height of the cylinder. The height of the cuboid, sorry. And if you put all that into a calculator, you get 502.4 centimetres cubed. Now, to get the volume remaining, you have to subtract 4 cylinders from the actual box shape, the cuboid. So to put that into mathematical terms, the total volume is the cuboid's volume, take away 4 lots of cylinders. So that's 8,000, and 4 lots of 502.4 come to 2009.6. The answer is 5,990.4 centimetres cubed. That's what's remaining. So if you have shapes inside other shapes and you're asked to calculate the remaining volume, it's always a takeaway sum.